Hello students, today we are going to learn a very important topic of physics, heating effect of electric current. So in this video we'll see what kind of heat is this and why heat is generated when electric current passes in a circuit. And next we'll see what are the uses of this heat generated by electric current, and finally uh, we'll also learn how to calculate the amount of heat generated and what are the conditions on which heat produced depends. Okay, so without wasting any more time, let's get started. Please watch the video till the end. First of all, let me tell you that heat is a form of energy, and the heat energy produced by electric current is called the heating effect of electric current. You must have experienced that whenever you keep some appliances, electric appliances, connected to electricity for a certain period of time, your appliances becomes a little bit hot. So it's a natural consequence. So this heat energy is many times wasted, but there are many useful applications of this heat energy. We use this heat energy in our many day-to-day appliances like electric iron, electric geyser, electric kettle, electric bulb, electric fuse, etc. Now the question is, how do we get this energy? So this heat energy, we get this heat energy from electrical energy. And electrical energy is possessed by moving electrons. You know that electric current is nothing but the flow of electrons. So moving electrons possess electrical energy. And again, the moving electrons get electrical energy from the battery or a cell, from the source energy. Okay, so thus we can say that electric current has electrical energy. A battery or a cell is the source of electrical energy. Thus, it means a battery or a cell gives energy to the electrons in order to set them in motion. So, in order to maintain the continuous flow of electric current, the source has to expend its energy. Actually, this energy is given to the electrons in order to bring them into motion, that will establish electric current. Thus, we can say that electric current has electrical energy, and this energy will be transformed into heat energy. Okay, thus electric current gets electrical energy from the source and carries it through the circuit. And in order to overcome the resistance offered by the conductor, you know that every conductor offers some resistance. So in order to overcome that resistance, the electric current has to lose its energy. Actually, the lost energy is converted into heat, because by the law of conservation of energy, energy can neither be created nor be destroyed. It can only be transformed from one form to the other. So, electrical energy is transformed into heat energy. Now, the next important point is, higher the resistance, higher is the amount of heat generated. If a conductor has high resistance, then the more energy will be lost while trying to overcome the resistance. So more amount of heat will be generated. So in a purely resistive conductor, okay, many times we have purely resistive conductors. So in that case, the entire electrical energy carried by the moving electrons is converted into heat energy. Like we have purely resistive conductors in electric heater, electric geyser, electric kettle, etc. So we can say that the heat energy produced by electric current, actually caused by the resistance offered by the conductor, this heat energy is equal to the electrical energy possessed by the moving electrons, possessed by the electric current. So heat energy is equal to the electrical energy that the electric current carries in the circuit. Okay, and you know that energy is nothing but the capacity to do work. So electrical energy is the work done by the source. Okay, the amount of work that is done to set the electrons in motion to establish electric current. So that much amount of energy is stored in the electrons. So the amount of energy that electric current has is equal to the work done by the source in order to establish the electric current. Thus you can see that heat energy is equal to electrical energy, and electrical energy is equal to the work done. So we can say that heat energy is equal to the work done by the source. Okay, in order to work on the electrons, the source has to expend its energy. So now we'll see how heat energy is connected with the work done. So here we go. As you can see in this new slide, heat energy represented by H is equal to electrical energy, that is represented by E. So H is equal to E is equal to W, that is work done by the source. And you know the formula W is equal to QV. You must have read in the previous part of this chapter. Okay, so finally we can write H is equal to QV, and again we will replace Q by IT, as you can as you know that electric current I is equal to Q upon T, so Q is equal to IT. So when we put the value of Q, we get H is equal to VIT. Again, you can replace V by its formula, V is equal to IR, by Ohm's law here. Okay, by Ohm's law we know that V is equal to IR. So when we put the value of V, we get H is equal to IR multiplied by IT. So finally we get H is equal to I square RT. And you know this is what is called Joule's law of heating. Okay, so what is Joule's law of heating? As from the expression H is equal to I square RT, we can say that the heat produced in a resistor is directly proportional to the square of current for a given resistance. Okay, so when electric current is doubled, then then the heat produced will get 4 times greater. If you double the electric current, the heat produced will be increased by 4 times. And next we can say the heat produced is directly proportional to resistance for a given current. If you double the resistance, the heat produced will also get doubled. And similar is the case with time. If you increase the time 3 times, then the heat produced will also get 3 times. So this is what is called Joule's law of heating. It's very important, so remember it. And you know that what is the SI unit of heat. The SI unit of heat is the same as the SI unit of energy or the work, that is joule. So this is all for today in this video. We'll see you all in my next video, in which we'll discuss what electric power is, what are different units of power, and how to calculate the amount of money that we will be charged for consuming a certain units of energy. We'll see what 1 unit of electrical energy means. Okay, so thanks for watching everyone. Bye, have a nice time.